The next kind of asymptote we're looking for are slant or oblique asymptotes. So basically, you've seen them before with hyperbolas, things like that. But you might have, a slant asymptote going one way, another going another way, and you have some function that's approaching, or I'm sorry, this one's not a function, some relation approaching the slant asymptotes. What's important to note is that these are linear. If it's a slant asymptote, it's going to be some number in x, then maybe plus or minus another number, because you should have an mx plus b. B might be 0, that's fine. M can be any number, but you're going to have an x to the first. To actually have this happen on an asymptote, when you look at your function, you look at your higher powers. X squared divided by an x, higher power in the numerator, higher power in the denominator. The difference can only be 1 to have a slant. It has to be 1 more in the numerator than the denominator, because x squared over x is just 1. I'm sorry, x squared over x is 1x. If you look at this one, x to the 4th over x cubed, there's a difference of 1 in the power, which means there could be a slant asymptote. So step 1 is just identification. Could there possibly be a slant asymptote? Yes, because the power in the numerator is 1 more than the highest power in the denominator. Step 2 is actually to try to figure out what it is. Well, to do that, I'm going to rewrite this function, and I'm going to rewrite it by using long division. So I'm going to say we have x squared minus 2x plus 4, and I'm going to divide by x minus 2. So x times an x equals x squared. I multiply down, x squared minus 2x. I'm going to subtract, so I'm going to change the signs. That cancels out, and I have a 4. Well, there's nothing I can multiply x by to get 4. So, I could divide, but I can't multiply, so that's actually done. So, another way to write this function is f of x equals, and it's x plus 4 over x minus 2. And if you aren't sure how this form works, imagine that you are doing 7 halves. So I'm going to do 7 divided by 2. 2 goes into 7 3 times, which is 6. Subtract, and it's a 1. You know 7 and a halves is 3 and a half. If you look, it's 3 plus your remainder over what you're dividing by, 3 and a half. So it's x plus 4 over x minus 2. Now imagine that I'm going far, far, far on the right-hand side of the graph. So x is approaching infinity. This is going to go towards infinity, this piece right here, but it's going to act like y equals x. So if I plug in 100, it's going to be 100. If I plug in 10,000, it's going to be a 10,000. This is going to actually turn into a really, really small number. So 4 over infinity minus 2, 4 over infinity, this piece is going to 0. So the further you go out towards the right on the graph, the more your graph is going to approach just this y equals x. If I go out towards negative infinity, the same thing's going to happen. Negative infinity minus 2 is a negative infinity. 4 divided by something that's so large in magnitude, whether it's positive or negative, is going to go to 0. And your graph will approach this. So you have a slant asymptote at y equals x. Now I actually knew that as soon as I got to right here, because as soon as you're done with the division that works, this is your asymptote. I know that this is going to go away. I also know that there could have only been one more step, because I said it had to be mx plus b. This is a 1x plus 0. There could have maybe been a number, but that was it. Okay, so we're going to look at this one. X to the 4th over x cubed. That's an x to the 1st if I actually do the division. So that's a clue that there could be a slant asymptote, and I'm going to divide. And the beauty of this is that no matter how complicated it looks, I can only possibly have to do the division twice. So I look at my first terms. X cubed times x is x to the 4th. I multiply down. I'm going to subtract, so I'll change my signs. This cancels out. This is the highest power, so negative 2x cubed plus 4x squared. Then I'm going to bring my plus x and minus 6. What do I multiply x cubed by to get a negative 2x cubed? And that's negative 2. And if you look, I already have my linear function. So it's going to be y equals x minus 2. And that's where my slant asymptote is. For my last one, I have x cubed over x squared. So it's going to be x to the first power. So I'm going to divide x cubed plus 5x minus 10 divided by x squared minus 4. And again, it's just an x. So x cubed minus 4x. Subtract, which means changing the signs. And this becomes 9x minus 10. X squared times what is 9x? There isn't anything, so I'm actually done. And my slant asymptote is at y equals x. And that's all there is to it.